In this video, we're going to be breaking down 100 facts about the Mariana Trench, from its incredible depths to the mysterious creatures that call it home. The Mariana Trench sits in the western Pacific Ocean like a massive underwater scar, stretching about 200 kilometers east of the Mariana Islands. Picture this: if you were floating above it, you'd be roughly 124 miles from Guam, that US territory you might know from the news. The trench curves through the ocean in a crescent shape, almost like a giant smile turned sideways, measuring an impressive 550 kilometers long. That's roughly the distance from New York to Denver, except it's all underwater and carved deep into the ocean floor. The width of this underwater canyon averages 69 kilometers at its widest point, which might not sound enormous until you realize that's wider than Manhattan, stretched out 43 times over. This crescent-shaped depression represents one of the most distinctive geological features on our planet, visible even from satellite images as a dark blue gash cutting through the lighter blue of the surrounding ocean. The trench maintains its curved profile throughout its entire length, following the contours where two massive pieces of Earth's crust meet in an underwater collision that's been happening for millions of years. The deepest part of the Mariana Trench has a name that sounds like something from an adventure novel: Challenger Deep. This is named after the HMS Challenger 2, the British research vessel that first measured its incredible depth back in 1951. The Challenger Deep sits at the southern end of the trench, and here's where things get mind-bending. It plunges down to approximately 10,984 meters below sea level, give or take 25 meters, depending on which measurement you trust. The precision of measuring something nearly 7 miles underwater is incredibly difficult, which is why different expeditions have recorded slightly different depths over the years. The most recent measurements using advanced sonar technology suggest the deepest point reaches 10,935 meters, but the exact figure continues to be refined as our technology improves. To put this depth into perspective, imagine taking Mount Everest, the tallest mountain on Earth at 848 meters, and dropping it straight down into Challenger Deep. The peak would still sit more than 2 kilometers underwater, with over a mile of ocean still above the world's tallest mountain. It's like nature decided that going really high wasn't impressive enough, so it went ahead and created something that goes impossibly deep instead. The water pressure at this depth is more than 0 times greater than at sea level, equivalent to having about 50 jumbo jets pressing down on every square meter. The Mariana Trench's location isn't random. It sits right where two massive pieces of Earth's crust meet in what geologists call a subduction zone. We're talking about the Pacific Plate and the smaller Philippine Sea Plate, and they're locked in an incredibly slow-motion geological wrestling match that's been going on for millions of years. The Pacific Plate, which is older, cooler, and denser, gets shoved underneath the Philippine Sea Plate in a process scientists call subduction. Think of it like sliding one piece of paper under another, except these pieces of paper are chunks of ocean floor, dozens of kilometers thick, and moving at about the same rate your fingernails grow. This collision happens so slowly that you'd never feel it in a human lifetime. But over geological timescales, it's one of the most powerful forces shaping our planet. The Pacific Plate carries some of the oldest oceanic crust on Earth as it dives into the trench. We're talking about seafloor that's up to 170 million years old, formed when dinosaurs were just hitting their stride in the Middle Jurassic period. As this ancient crust descends into the Earth's mantle, it gets recycled back into the planet's interior, completing a cycle that has been going on since the earliest days of plate tectonics. The angle of this descent creates the steep walls of the trench, with the deepest parts formed where the descending plate bends most sharply as it begins its journey into the Earth's interior. Here's something that might surprise you about the Mariana Trench's neighborhood. It's part of a much larger system called the Izu-Bonin-Mariana Subduction Zone. This is part of a geological family that includes other deep-sea trenches stretching across the western Pacific. The whole system forms a boundary between tectonic plates that runs for thousands of kilometers, making the Mariana Trench just one member of an exclusive club of Earth's deepest places. This subduction system is responsible for some of the most dramatic underwater topography on our planet, creating not just the Mariana Trench, but also a series of underwater mountains, volcanic islands, and smaller trenches that dot the western Pacific. The system is incredibly active, geologically speaking, generating earthquakes, volcanic eruptions, and the constant recycling of oceanic crust. What makes the Mariana section special is that it represents the deepest point in this entire system, the place where the geometry of the plate collision and the age of the descending crust combine to create maximum depth. The surrounding trenches, like the Japan Trench and the Philippines Trench, are also incredibly deep, but none quite match the extreme depths found in the Mariana system. This entire network of trenches forms part of the Pacific Ring of Fire, that famous circle of seismic and volcanic activity that surrounds the Pacific Ocean. The coordinates of Challenger Deep, if you're the type who likes to look things up on maps, are approximately 1122.4 N 142.35.5 E. Now, those numbers might seem meaningless, but they pinpoint one of the most remote and extreme locations accessible on our planet. You're more likely to have cell phone service in some parts of Antarctica than you are to have any kind of communication with the outside world when you're floating directly above this spot. These coordinates place Challenger Deep in what's essentially the middle of nowhere in terms of human civilization, thousands of miles from major population centers and hundreds of miles from the nearest significant land masses. The remoteness of this location has made it one of the least explored places on Earth, visited by fewer people than have walked on the Moon. The coordinates also place it in the tropics, which means the surface waters above are warm and teeming with life, creating a stark contrast to the cold, dark depths below. Interestingly, these coordinates have been refined over the decades as GPS technology has improved, and different expeditions have sometimes recorded slightly different positions for the deepest point, reflecting both the challenges of precise navigation at sea and the fact that the deepest point isn't a single spot, but rather a small area of extremely deep sea floor. The precision required to navigate to this exact location in the vast Pacific Ocean is a testament to modern technology. Without GPS satellites, finding this needle in an oceanic haystack would be nearly impossible. Speaking of remote locations, the nearest land to Challenger Deep is Face Island, one of the outer islands of Yap, sitting 287 kilometers to the southwest. Guam, which is much larger and more well-known, lies 304 kilometers to the northeast. To put this isolation in perspective, you could fit the entire state of Rhode Island in the empty ocean space between Challenger Deep and the nearest significant landmass, with room to spare. Fayas Island itself is tiny, just 2.8 square kilometers of coral and palm trees rising barely above sea level, home to fewer than 300 people who live a traditional Pacific Island lifestyle largely unchanged for generations. The contrast between this small tropical paradise and the abyssal depths of Challenger Deep just a few hundred kilometers away is one of the most dramatic geographical contrasts on our planet. Guam, while much larger and more developed, is still a relatively small island in the vast Pacific, serving as an important military and commercial hub for the region, but still feeling incredibly isolated when you're floating above the deepest part of the ocean. The distance to any major continental landmass is even more staggering. You'd have to travel over 0 kilometers to reach the Philippines, Japan, or Australia. This isolation has helped preserve the pristine nature of the deep sea environment around the trench, as human impacts have been minimal compared to coastal areas near major population centers. The remoteness also means that any research expedition to the trench requires careful planning and substantial resources, as rescue or resupply would take days or weeks to arrive in case of emergency. The Pacific Ring of Fire, that infamous circle of volcanoes and earthquake activity that surrounds the Pacific Ocean, includes the Mariana Trench as one of its most dramatic features. The Ring of Fire gets its name from all the volcanic activity, and the Mariana Trench sits right in the middle of this geological hot zone. It's like living in the most seismically active neighborhood on Earth, except your neighborhood is 7 miles underwater. The Ring of Fire is responsible for about 90% of the world's earthquakes and contains 75% of the world's active volcanoes, making it the most geologically active region on our planet. The Mariana Trench represents the deepest point in this ring of geological activity, where the forces that drive earthquakes and volcanoes are at their most extreme. The subduction process that created the trench continues to generate seismic activity, with deep earthquakes occurring regularly as the Pacific Plate grinds its way beneath the Philippine Sea Plate. These earthquakes can be felt hundreds of kilometers away and sometimes generate tsunamis that affect the entire Pacific Basin. The volcanic activity associated with this subduction zone has created the Mariana Islands themselves, along with numerous underwater volcanoes and hydrothermal vents that dot the seafloor around the trench. Some of these underwater volcanoes are active today, spewing lava and superheated water into the deep ocean, creating unique ecosystems that thrive in conditions that would be instantly lethal to most life on Earth. The Ring of Fire designation reminds us that the Mariana Trench is part of a dynamic, ever-changing system that continues to shape our planet today. The formation of the Mariana Trench is directly responsible for creating the Mariana Islands themselves, in what amounts to one of Earth's most impressive geological recycling programs. As the Pacific Plate gets forced down into the Earth's mantle, it carries water trapped in its rocks and minerals. When that water gets released under the extreme heat and pressure deep underground, it causes the rock above to melt and form magma. That magma eventually finds its way to the surface, creating the volcanic islands we see today. It's like the Earth's own recycling program, except instead of making new bottles, it's making new islands. The process works because the descending oceanic plate contains water locked in its crystal structure, and as the plate descends and heats up, this water is released and rises into the overlying mantle rock. Water lowers the melting point of rock, so the addition of this released water causes the mantle to partially melt, creating magma that's less dense than the surrounding solid rock. This magma rises toward the surface, sometimes erupting underwater to build seamounts and volcanic ridges, and sometimes breaking through the ocean surface to create islands. The Mariana Islands are the surface expression of this deep Earth process, representing just the tips of massive volcanic mountains that rise from the ocean floor. The largest of these islands, Guam, rises over 0 meters from the seafloor to its highest point, making it part of a mountain range that, if measured from base to peak, rivals some of the tallest mountains on the continents. This island-building process continues today, with active volcanism still occurring in the region, slowly adding new land to the existing islands and potentially creating new ones over geological time. The age of the oceanic crust that's diving down into the Mariana Trench is absolutely mind-boggling. We're talking about some of the oldest oceanic crust on Earth, up to 170 million years old. To put that in perspective, this piece of ocean floor was forming when dinosaurs were just hitting their stride in the Middle Jurassic period. The rocks diving into this trench are older than the Atlantic Ocean itself, which didn't even start forming until about 130 million years ago. This ancient oceanic crust formed at mid-ocean ridges that no longer exist, created when the continents were arranged very differently than they are today. At that time, the supercontinent Pangaea was just beginning to break apart, and the Pacific Ocean was much smaller than it is today. The crust now descending into the Mariana Trench has been slowly moving across the Pacific for all these millions of years, covering thousands of kilometers at the rate of a few centimeters per year. During its long journey, this oceanic crust has accumulated sediments, been altered by seawater, and cooled from its original molten state into the dense, cold rock that now makes it heavy enough to sink back into the mantle. The extreme age of this crust is one reason why the Mariana Trench is so deep. Older oceanic crust is colder and denser than younger crust, so it sinks more readily into the underlying mantle. This creates steeper subduction angles and deeper trenches compared to areas where younger, more buoyant oceanic crust is being subducted. The recycling of this ancient crust back into the mantle completes a cycle that has been operating for billions of years, constantly renewing the ocean floor and helping to regulate the Earth's internal heat and chemical composition. The shape of the trench isn't uniform throughout its length. It's actually made up of 3 distinct basins that scientists have creatively named the Western, Central, and Eastern basins. Each basin has its own personality, with slightly different depths and characteristics that reflect the complex geometry of the subduction process. The Eastern Basin currently holds the record for the deepest measured point, though the differences between the 3 are relatively small when you're talking about depths that boggle the human mind. These basins are separated by underwater ridges and mounds that rise several hundred meters above the deepest parts, creating a landscape that looks somewhat like a series of connected swimming pools when viewed from above with sonar. The Western Basin, where the famous Trieste dive took place in 1960, reaches depths of over 900 meters and is characterized by relatively flat, sediment-covered floors. The Central Basin is slightly shallower, but features some of the most interesting geological formations, including evidence of underwater landslides and complex current patterns that have carved unusual features into the seafloor. The Eastern Basin, the current record holder for depth, is the narrowest of the 3, but appears to have the steepest walls and the most dramatic topography. Each basin represents a slightly different phase or aspect of the subduction process, with variations in the angle of the descending plate, the amount of sediment being carried down, and the local stress patterns in the overlying crust. These variations create the complex 3-dimensional structure of the trench, making it not just a simple V-shaped cut in the ocean floor, but a sophisticated landscape of peaks, valleys, and basins that continues to evolve as the subduction process continues. That's it for today. If you want to learn more about the Mariana Trench, subscribe to our channel, and I'll see you in the next video about its deep secrets.